several people gone today. As we are moving forward now, so we were talking about angles. Today we're going to talk about angles in the perspective of right triangles. And so this whole lesson really is straight review. Doesn't mean you remember it. We covered it in Algebra 2 late in second semester. It was also covered in geometry. And so let's review some of our vocabulary. Inside specifically right triangles, we have some functions that are defined by the ratio of sides. So I'm going to go ahead and make a right triangle. I'm going to choose to put theta in the bottom corner. And in a right triangle, we have a special name for the name of opposite the 90-degree angle. What is that called? It's called the hypotenuse. You're going to see me abbreviate it as HYP today, or H. And then we have two sides, and the sides are in relationship to the angle. So in this particular case, this side here we would call the opposite side, but it's opposite the angle that I'm given. Again, if I was talking about the angle up here, it would be different, okay? And this side would be adjacent to theta. The functions sine, cosine, and tangent represent then the ratios given by any right triangle, and sine is going to be the length of the opposite side divided by the hypotenuse. The cosine is the adjacent over the hypotenuse. Tangent is opposite or adjacent. What's the way that you learned to memorize this? Oh, look at you. So Toa. Okay. And the reason we use it is because the S is sine, opposite over hypotenuse. The C is cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Last year, so that's geometry. Last year, we introduced the three reciprocal functions. I don't know if you remember this. And they were a little different. This one was called cosecant. And the thing that was tricky about cosecant is you would think it would be the reciprocal of cosine, but it is not. Don't know why. And then we have the secant, which you would think is the reciprocal of the sine, but it's actually the reciprocal of the cosine. And then the one that is as it seems is cotangent because it has the word tangent in it. Cotangent is the reciprocal of the tangent. So you're going to see here, do you see these abbreviations? CSC is cosecant, SEC is secant, COT is cotangent. And I wrote the reciprocal, but I'm going to also write below is I am going to also then flip the side. So if I was dealing with a triangle, we flip the fraction if we're finding the reciprocal. So cosecant, if I took the reciprocal of opposite over hypotenuse, another way of thinking of it is hypotenuse over opposite. Since secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse, another way of thinking of it is if I did hypotenuse over adjacent. And cotangent, if I took the reciprocal of tangent instead of opposite over adjacent, another way of thinking of it is adjacent over opposite. Okay. Just give me a little indicator who remembers this. Okay, a little thumbs up, thumbs down action. All right, thank you. So the first thing I'm going to show you is how you can use these in a triangle and just write them as fractions. We have to find the missing side first, though. Any ideas on that? In a right triangle, if I know two of the signs, how can I find the other? Pythagorean theorem, yes. I am going to need, you're right, I have one of them. Keegan, you were saying it's cosine. You're right, you do have the cosine. But if I wanted to find the other ones, I'd need the opposite piece. And so I'm going to do Pythagorean theorem. So 21 squared plus x squared equals 29 squared. we get 441 plus x squared. What's 29 squared? 841. What do we do now? Subtract the 441, right? You get 400. This one's a nice one today. If guys, let's say you get like 19. Don't round it. Leave it as root 19 today. Okay, just don't bother giving me decimals. Root 400, we know. If you took the square root of 400, isn't it 20? Okay. So this piece is 20. All right, so I'm going to do my 3 sine. So opposite hypotenuse. So here's my angle, opposite 20 over 29. Cosine, ka, adjacent over hypotenuse. So here's adjacent over hypotenuse, 21 over 29. Tangent. Tangent is which one? What over what? Opposite over adjacent. So 20 over 21. I think the easiest, because I asked you for all 6 then, is to write the reciprocal right next to it and then just flip that fraction. So the reciprocal of sine is cosecant. So I'm going to write CSC. I flip or take the reciprocal, which would then make it 29 over 20. The reciprocal of cosine is secant, CEC of theta, and that would be 29 over 21. And then cotangent, 21 over 20. Okay. Not too bad. So what if instead I give you one of the 6 and I ask you to find the others? Well, we're going to draw, I'm going to call this a reference triangle. We're going to draw a right triangle. And I'm going to put theta in the corner. And what's tangent the ratio of? Opposite over adjacent, right? And I'm telling you it's 5 over 12. So what can you put in the opposite spot? The 5. And the adjacent spot, you can put the 12. All right. Would you find this missing side piece for me? So we get 13. And I think you can go from there. Let's just at least do the regular ones. So sine would be, by regular, I mean the non-reciprocal ones. Sine would be opposite over hypotenuse, so it would be 5 over 13. Cosine would be adjacent over hypotenuse, so 12 over 13, and then you could go from there. Okay. How are we feeling so far? You can give me an indicator if you want. Okay, then the other thing is that I wanted to talk about for just a minute is on your calculators, there's the sine, cosine, and tangent buttons, okay? Well, a couple things. First of all, we might be using these today. When we're using these, it matters what mode you're in, okay? Because we're going to see something in both degrees and radians. And if it's a degree measure, your calculator will actually calculate these rates for you. Now, if you don't know the angle, you have to use the ratio of sides. But let's say I told you, hey, there's a 27-degree angle here. And I said, what's the sine of 27? Your calculator will do that for you. You just make sure, first of all, is this degree or radians? Degrees. So you would want to make sure you're in degree mode. So you go to mode, make sure you're in degree mode. And then you would say the sine of 27, and it's going to give you, that's the ratio of the opposite over hypotenuse. It's going to give it to you rounded. This is where I told you last year that when I was a kid, they didn't have calculators that did this, and I had to go look this up in the back of a book. They had all the angles listed in the back of the book, and I know. What did I tell you yesterday that was made me really old? There's something I told you.
The journey table.
The record player? Yes. Yeah. Forgot about that. It's all these things. I didn't even know how old I am. I'm so old that my son is 20 today. That's so sad. Okay. Anyways, I digress. I'm so sorry. So, if you get to the section that says, hey, find this angle literally using a calculator. Well, what if I said, hey, what's the sine of pi eighths? What's that in? Radians. Well, then you want to switch your mode and make sure you're in radians. Well, it is. Or you could go find a textbook and look it up in the back. What's easier? Then stop complaining about the buttons. All right. So that's a little how that works. Little word of warning, there's no cosecant, secant, and cotangent button, so you'd have to do 1 divided by. These here are inverses. Those are not the same thing. They're not cosecant and secant and tangent. Those undo angles. I don't know if you remember that from last year. They undo angles. Like if you knew this cosine and you wanted to know the angle, they go backwards. So something totally different. All right, so